then do a little editing later. So for those of you following along at home later, when you have all kinds of extra questions and you're going, wait, I don't remember where any of that nonsense was, this will maybe help be a guided post for you. So we're going to go to mathworks.com. You guys are going to sign in with your accounts. So you're going to click the little person at the top, sign in with your account using your GCU credentials. And what that'll allow you to do is that will allow you to access what's called your OneDrive. You can also actually get Matlab from here. So if you haven't completed the install, you want to get that running immediately, because that'll take a little while to make that happen. There is an online version that if you guys are waiting on your downloads, you can at least open up the online version and probably work with the data set there, because you should be able to load in stuff from your example. So you should be able to click one of your data files. So those of you that have Chromebooks, you might be able to run this, maybe. Don't know for sure. Haven't tried it, wouldn't be surprised if there were issues, because the support for Chromebooks is exceedingly limited. But what you should be able to do is at least load in the data set. So once you load in the data set, you'll have the orientation, and I'll switch back over to once you've downloaded this from your OneDrive. When you click the link, you can get the data set. It'll end in .mat. So that's going to be your Matlab data file. So you'll also have the actual copy of Matlab open if you're working on the desktop. And once you load it in, it'll look something like this, where if I clear everything real quick so we can look at what the import looks like, there's a couple ways to do it. Starting from the Home tab, if you've already got it open, you can click the Data Import, or you can navigate to where that file is. That will also come in through the Data Importer, the Data Import Wizard. You're going to select the ones you want, in this case something like orientation, to give us all of the angles, and that will bring this in. All right. So when you go to look at this, you'll see, hey, look, there's all my data. So it should look about the same in the online version. So I'll take a look at that real quick so that you guys can see it. If we open the table, loads in with all of your data. I think the online one is a little bit more laggy, and there are some features and things that aren't as well supported in the online version, so you want to try and be running the desktop version whenever possible. But if you're having issues with it that day, or it can't validate the license, or heaven forbid some other stupid thing happen, right? Because that's definitely not something we'll see a lot of this semester, is you can go in here and actually get it open. So you'll have these different X, Y, and Z axes, right? So remember back when I told you guys what was going to be the case for, you had to pay attention to what the angles were and which one was which. So it doesn't come through with labels, it just tells you X, Y, and Z, right? So which one's which? Can anyone tell just by looking?
The middle one is pitch.
So the middle one should be pitch. So what are the other two? If Y should be pitch, that one should stay fairly constant, unless of course there's some other issue, you're super vitamin B deficient that day or something, you're shaking all over the place, right? Or maybe you've had one too many stampedes, right? That never happens. So as you're trying to aim it at whatever object you're trying to measure, right? Because we're thinking in terms of trigonometry from this lab. So we know that center one, Y, is the one that we're interested in. The other two are a little bit less important. So depending on just how vitamin B deficient you are that day, you'll have a little variance. But what we want to do is we want to take that data set and pull it out. Now there's a couple different ways when we're working in Matlab, just like in any other type of software, there's a couple things you can do. One of them, if you guys are really struggling with Matlab altogether, is you can take that column, and you should be able to copy this and drop it into something like Excel. For this purpose and this analysis, we don't necessarily have to do it in Matlab, but you're going to need Matlab to open the actual data set, and so it'll tell you something like this data set is incomplete, so it won't give you the info that you need. So instead, this one, let's see, we can do an export from, to Excel, but from the timetable, the format for the data is just not going to be helpful. So what we want to do is we want to pull a variable, and we'll say something like, we'll give it a name, something like angle. And then there's a couple ways that we can use things like the help to get us the information that we're looking for out of this data table. The problem is there's a few different ways to capture data, and in order to not teach you all of the fundamentals of how this works, the simplest is just going to be to show you a couple examples. So one of them is going to be by using the specific name. So in this case, orientation. So angle is going to be, we're going to assign this orientation, and you guys will learn a lot more detail about some of these differences in later semesters when you go to do programming. But for now, just suffice it to say there's a difference in how we call information out of something. So whenever we're trying to get the information, we're going to try and get orientation, and then depending on whether you use parentheses or braces or brackets, you're going to get different kinds of information pulled out of these. So if this is orientation and we want to do column, so it's almost always row and then column. So to get all of them, the notation is something like this, where you're doing telling Matlab all rows and column 2. In this case, technically, timestamp is going to be that's part of the X label, so that might pull data from the second set. So we're going to look at what that gives us, and it's going to give us the initial X label, and it is going to give us the information that we're looking for. So column 2, it does actually keep, but it also gives us the X label. So it shows up with a new variable that we just created called angle, and this pulls all of the data just out of the column of interest, but this one still doesn't give us exactly what we're looking for. So a quick little hint in this command window, instead of retyping everything we just did, you type up, the up arrow, and this gives you a little more, gives you the copy of whatever you just entered. We'll learn later how to do some of the fancier stuff and actually work in M files and do commands. For the moment, we don't strictly need that. We're just trying to keep things as simple and basic as possible. So there's also a method that we can use, and one of the easiest examples, I already have a file that shows the syntax, instead of all the other things that we want to take a look at. Let's do this. I've got an example here of an actual issue with the directory. So this is actually another thing that you guys will want to pay attention to when you're working with Matlab, depending on where you've installed it. You generally don't want to have downloads as your directory. So the directory is this file path. The quick way, especially on a Windows machine, to know what the directory is to the files that you want to be using. Matlab is very, very particular about this. Whole long story why. Details don't really matter for you guys for now. You'll learn more about that later. You just want to have really good discipline about this. So you want to go to, in your File Explorer window, you want to go to this, this path is what it's referred to as. And you want to copy that file path and then paste this into your path in Matlab, because this is where you want to make sure that it's going to your documents and Matlab, so that you don't have data sets that you're working on a file, you're saving it in something like, very often when you guys do a download, it'll open up in a temporary file, app data or roaming data that's a temporary file, and then those files don't always get saved and they periodically get wiped, like when you do a reboot and things. So that's really bad for business, as it turns out. So you want to make sure that you're aware of what your file location is, and that's why I'm recording a bunch of these little details for you guys to go back and look at later when you go to do stuff and then forget, 90% of whatever we did in class. So the good news is this way you guys are at least in person asleep in class instead of on Zoom with your camera off playing Minecraft parkour, right? So it's a little less fun, but about the same level of productivity. So we want to find, in this case, I've got an example of a data pull that we're going to use a lot, and I think we have this added in. Whenever you have a grayed out file, what you're going to do is you're going to add this to path. So you're going to right click it, add it to path. You want to click select folders and subfolders. Every time you reopen, if there's a file that you need information from, and I believe this one is also located in Halo. As far as I know, the data pull should be attached to the actual assignment as well. And so this one, this should be part of the prompt, but if this is also messed up or doesn't include the information, then yeah, this should include the data pull, but they don't have that information in the resources either. So it's good that I'm actually doing a record of this. All right, so back in Matlab, we have one of the files that is for sure included a couple different variations of this later in the semester. I'll just open this now. We don't need to do the load files, but we do need to follow essentially this. We do need to follow essentially this format. This is going to store data, and so instead of walking you through a number of these, you'll see these later in the semester where we're pulling data from Matlab Mobile fairly often. Instead of using these parentheses, we're going to do the same kind of thing here that we're going to do later in the semester where you have to use curly braces. I'm going to show you real quick what the error looks like if you use just the brackets. It does some strange and unusual things and says, I don't even know what the heck this is. If you use the curly braces, you can actually get the same kind of data. This has to do with pulling information out of a data table. So what you'll see is we've now reassigned this as a different data type. This is now called a double. What this means is, among other things, you can actually much more easily copy this data set. So I believe this one you can actually copy as is and drop into Excel. And so that's the part that you guys are probably most interested in, is being able to drop this into Excel and then see it a little bit more easily. You're probably a little bit more familiar with some of the data analysis in Excel, but this is what's called a double precision array. This allows us to actually do a lot of operations either in Matlab or in Excel. And for the purposes of this lab, either are acceptable, but now that we have our array, it'll be much more useful to work in an M file if we're trying to do graphing and other things. For the moment, instead of trying to teach you the fundamentals of all of the rest of these operations, you want to enter this command so that you can generate a series, and what you'll do is for each of these, you want to generate that data set and then drop it into Excel, and for each one, you'll want to add in a label. So you'll want to insert another row, and then you want to add in a label. So this is going to be maybe this one. So in my case, this is the projector. This next one, so you guys are going to have things like the stadium. You're going to have the statue, and you're going to have the circle, right? So the circle. So those are the data sets that you're going to be pulling in from your phone, and then you're going to be working in Excel to do some analysis, because you guys will be, I think, a little bit quicker in picking this up. And especially for something like this, you can see when and where you're getting things lined up, right? And you've got some sort of a pseudo-steady angle at the end or at some portion of your data set. So you're going to need to kind of build some kind of an instinct for what this looks like. And one of the easiest ways to tell what's going on is going to be before you even do any other analysis, Excel kind of has some sort of a sense of what you're going to do, at least in terms of if you're doing lots of the same things over and over and over again. You'll see at the bottom, you'll get information about the sum, the actual number of data points, and then the average. So in this case, minus 24.82. So we got to think about for a second, okay, especially as you're looking at your phone and you're looking, if you flip one of those sensors back on for orientation, what does that mean, minus 24? Anyone figure that out? 24 degrees from what? From something, right? So I'm going to bring back up our slides here. Actually, I can do it here at the back of this one. So 24 degrees down from what? So I need another drawing object here to give you a reference point. 24 degrees here. So I'm going to do a quick arc. And if I can get that oriented in a way that sort of kind of makes a little bit of sense here. Maybe I can get it to be a little more uniform. Nope, since it's Word, it's not really designed to be a curve program, but we'll just make the best of what we can for the moment. So we have some kind of an angle from the horizon, right? So this would be the horizon. And you'll have to think back in your trig days. This is our theta, right? So we actually have the ability, in at least this case, we should have the ability to add in symbols, but they're being a little cheeky at the moment, so can't add in symbols. So we'll go back to another text object, and we'll just refer to this as theta. So this is our angle theta, and so this is where our phone is. So we will do, oh, they don't have a preloaded example, so we'll just do this one for example of the phone. So this is our phone, this is our orientation relative to the horizon, right? The way to think about the horizon is either like it's the floor or like it's the ceiling. At the end of the day, if you remember all the fundamentals of trig, doesn't matter which of those parallels you pick, the angle is going to be the same, right? So in this case, relative to, we'll call it the ceiling for the purposes of discussion, we had the projector, and so the projector is what I was measuring, and this one has some kind of composite. In this case, we have some kind of light source, right? So this is our projector. So the phone is measuring that angle theta relative to the horizon, in this case the ceiling, and that's what your data set starts from. So could be the ceiling, could be the sky, something like that, right? We'll do a title case there for the sake of continuity. All right, so we have our projector, and we want to know something about those distances, right? So we can determine, based on this, what our effective triangle is to the phone by knowing how far away we are, right, along the top line. So what is our distance from the object, and then from our angle, okay? So those are the hints that I'll give you guys as far as how you're thinking about the data processing. Because the cool thing is, when you're working in Excel with one of the data sets, you can use a lot of formulas, right? In this case, I know somewhere around where it was 28, 29, 30 degrees, I was still kind of finding position. So I know offhand, I don't specifically need that first group of the data block. So right after about 30, about 28, it starts to settle. So I can take these, and since my right click is not working, that's exceedingly annoying. There we go. So I can delete those particular rows, and then I'm left with the part of the data that I'm interested in. So then at the bottom, I can take an average and use the formula for average, right? And if I were using some kind of fancy trig function, we can do the same thing in Matlab, and I'll show you what that looks like. So that way you guys have some degree of completion for how to use the software. We can estimate our distance, right? Because we might be measuring that based on some kind of a change in the GPS data or something like that, right? Maybe we walked our paces and figured out how far away we are from things when we took that measurement, right? And in this case, I can estimate my distance at, for this, about, I want to call that about 9 feet away. So we'll say 9, and I'm going to note the units because units are important. So we need to know approximately how far away stuff is. And then based on that, I can get some kind of an estimation of what my distance was, right? So about 9 feet away, about minus 24 degrees, and then I can use my output. Anyone know what function that's going to be that I need to use? I mean, not like your participation points are at stake or anything, right? So think about it for a second. Again, looking at this. So think about, we have our angle here, and we have our adjacent, right? This is the adjacent side. Go back through SOHCAHTOA. Tangent would be opposite this height, right, over adjacent. So if we know something about the height from our phone, we can figure out something, because it may not be the distance necessarily from it might not be the distance from the ground, right? Because the ground might actually be here. Right? So this might be the ground. So we still need to know something about this height in order to know something about how far this is. So you still have to do a little bit of figuring and estimating, right? Was your hand 4 feet off the ground, 5 feet off the ground, 8 feet off the ground, right? You still need to know something about your height. So you're going to have two components of that distance. You're going to have the height from the triangle plus the height from your phone to the ground, right? And whatever combination of math gets you there, you want to start with something like tangent, because that's going to give you the opposite over adjacent. And that's what you want to work with, is the tangent for that angle. The problem is, in order to get that, you have to solve for it algebraically, right? You have to solve for this opposite. So I'm going to let you guys work on that and show you can do the same thing here in Matlab, and we don't have to have a fancy M file for it. So I'll just go down to the bottom here and show you an example. If you wanted to take, for instance, the average, there are a couple really neat functions that you can use, and in this case they give you a lot of examples of things like math functions, anything from trig and graphing and other fancy things. All of this is available. So it's kind of cheating the way that they have this in the software now. But you can go in and say, what if I wanted to take an average? And so it will tell you what that function is in this language. So if we want an average, we would need the mean of, and an array name, in this case, angle, and it'll give you some hints and dimensions and other things like that. And so you can just tell it the mean of an angle. You can also click the help and some other things, especially as you add this and then you're waiting. You can click the more help and it'll bring up the help window and show you a lot more information about syntax and all kinds of useful things. The help is very useful on Matlab to show you examples of what the syntax looks like. For this purpose, we can take the mean of the angle. If for some reason you don't have Excel installed, and you can say OK, and the answer will give you, it'll give you the answer. You can also specify the range and some other fancy things in there, but you can do the same kinds of functions. And then you could say, I want to do another function, and I want to do the tangent. So there's a couple different options. The tangent, and then you'll notice down here they have a tan, which is the inverse tangent, but you have to pay attention to the fact that it's in radians and not in degrees. Everyone remember the difference? Something about pi and 180 and stuff like that. The good news is you guys will probably Google it anyway just to remember what it looks like, right? So inverse tangent you can also use, and so all of these things are there. Similarly in Excel, if you're trying to find formulas and stuff, you can come down here and they have stuff already ready in trig, and you can do things like a cosine, the arc cosine or inverse cosine, right? arc sine, and then there it is, arctangent. So you can also get help on these, and you can say, all right, I really need the arctangent of some kind of a number, and it'll output what this is and give you a little bit of information about it. And so what you want to know is what that difference is. So this will tell you something, but it's up to you guys to figure out what that height is. So this is technically height to phone, and then you're going to have to figure out the height of the phone, and then come up with the composite height. To figure out exactly how tall things are. All right? So I'm going to let you guys take it from there. That should cover the majority of what you need in terms of the actual data.